Hello everyone, Mr. Cruze here with another trigonometry review for you. This time we're going to finish up the 3.3 to 3.4 quiz review. Alright, let's dive right in. As always, you can ask questions at any time. Tweet me, email me, post comments on this video, or come in the morning for help. That'd be a novel concept, right? But let's try this. So, again, we were proving these identities last time. So we're trying to get the left side to be equal to the right side, or vice versa. Pick whichever side is more complicated, right? So number 8, secant cubed x minus cosine cubed x over secant x minus cosine x. I think that's a little more complicated than the other side, right? I see this and I'm tempted to think about a difference of cubes, right? Which, if you remember, factors into x minus y, x squared plus xy plus y squared, right? You'll notice same sign in the middle, opposite sign, and then always positive. All right. Well, let's do it with secant cubed and cosine cubed. So it now becomes secant x minus cosine x times secant squared x plus secant x cosine x plus cosine squared x all over secant x minus cosine x. All I did was factor it, right? It still has the same format, x minus y, x squared plus xy plus y squared, right? The secant x minus cosine x is cancel, and I'm left with secant squared x plus secant x cosine x plus cosine squared x. You notice we look very similar to where we're headed, but this time secant x cosine x equals 1. That's one of our properties. So you get secant squared x plus 1 plus cosine squared x, which is exactly where we want to be. All right. Again, you can use this list of properties on your quiz tomorrow, as well as the table of values, okay? The next one, tangent theta plus pi over 2. On this one, you might be tempted to think to use the tangent of a plus b formula. But if you do, I think you end up with a little bit of an issue on the bottom, right? Well, actually, even on the top. You end up with tangent theta plus tangent pi over 2. And tangent pi over 2 is undefined, right? And we end up with some crazy stuff happening. So let's try something else, all right? Here's what we're going to do. I'm going to rewrite this as sine of theta plus pi over 2 over cosine of theta plus pi over 2, all right? And then I do have something for sine a plus b over cosine of a plus b. I do have something for that. Sine of a plus b is sine of a cosine b plus cosine a sine b, right? Over, we have cosine of a plus b, but that's cosine a cosine b, minus sine a sine b. And then we can start filling some stuff in, right? Like cosine of pi over 2, for instance, is 0. Well, sine theta times cosine pi over 2 is 0. Plus sine pi over 2, we have another one, that's 1. So we end up with 1 times cosine, or cosine, over, again, cosine of pi over 2 is 0, so this becomes 0, minus 1 times sine theta, which is sine theta. Now, this ends up becoming cosine theta over negative sine theta, which is negative cotangent theta, which is what we wanted it to be. So it depends. Sometimes there are some ways to write it where it'll work out nice, and others not so much. All right, last ones, 10 through 12. We got to write the general equation for the solutions, and then find the values in the domain either between 0 and 360 or 0 and 2 pi, whichever works. All right. This one we have sine theta cosine theta equals negative 1/4. I seem to have something for 2 sine theta cosine theta, right? But I have sine theta this time. I need to get a 2 over there, so I'm going to multiply both sides by 2. So I end up with 2 sine theta cosine theta, and that equals negative 1/2. Well, 2 sine theta cosine theta is sine of 2 theta. All right, now I'm going to take the inverse sine. 2 theta equals the inverse sine of negative 1/2. I need to know what are all the values where sine is negative 1/2. So you go to your handy-dandy table, and you figure that out. So 2 theta ends up equaling, there's a couple places where this happens. It ends up happening at 210 degrees, right? Plus some multiple of 360 degrees. And it also happens at 330 degrees, plus some multiple of 360 degrees. Last thing, we need to divide everything by 2. So we end up with theta equals 210 divided by 2 would be 105 degrees, plus some multiple of 180 degrees. And this one would end up being 165 plus some multiple of 180, right? So now that's our general solution. We just need to figure out, when does it happen between 0 and 360 degrees? Well, let's take a look at this first part. Obviously, I can't subtract 180 from 105, otherwise I end up in negative, which is below 0. So 105 is the first one that happens. Of course, I can add another 180 and I'll still be in 360. So 180 plus 105 is 285. And if I add another 180, I'll end up outside of 360. Let's do this one, 165. Again, can't subtract 180, so 165 is 1. And we can add another 180, and that will be 345 degrees. So all 4 of these will work for this particular problem. All right, let's try the next one. Sine 2x sine x equals cosine x. All right. This one's going to take a little bit of work. I see sine 2x there. I'm going to rewrite that as 2 sine x cosine x. Now, we still have another sine there, and then it equals cosine x. Becomes 2 sine squared x cosine x equals cosine x, and the temptation is to want to divide by cosine x. But remember, anytime you try to divide by something with an x, you'll end up deleting some of your answers, and you don't want to do that. So I'm going to actually subtract cosine x from both sides, minus cosine x, and now it equals 0. And then I can think back to algebra 2, and I can factor out a cosine x. When I do, basically it's effectively almost like dividing it, but it doesn't really divide in the sense that it gets rid of it completely, because it still exists out front, right? And then hopefully you remember from algebra 1 that you can set each of these factors equal to 0. So we have cosine x equals 0. We'll deal with that in a second. And then we have 2 sine squared x minus 1 equals 0. Cosine x equals 0, well, where does that happen at? Well, that means it's the arc where its cosine is 0, and that happens at pi over 2 plus some multiple of 2 pi n. All right. It also technically happens at negative pi over 2. You remember cosine's the plus or minus. But if you're using your table, which you might as well use, won't that be the same as 3 pi over 2? Might as well use that table to your advantage, right? And again, nothing extra that you have to do there. We just took the inverse cosine, right? X equaled the inverse cosine of 0. And that's exactly where that happened. All right, now for this guy. I'm going to add 1. 2 sine squared x equals 1. So the sine squared is 1/2. Well, that's fine and dandy. My table gives me sine, not sine squared. So I'm going to take the square root. Now, a word of caution. Whenever you put in your own square root, you have to remember to put in plus or minus because it could be either or. Now, remember, square root of 1/2 is the same thing as square root of 1 over square root of 2, which is basically 1 over square root of 2, right? We know that as radical 2 over 2. So now we need to figure out, well, what values of sine give us a positive or a negative radical 2 over 2? So basically there's 2 possible answers here, right? One where it's rad 2 over 2 and one where it's negative rad 2 over 2. So again, 2 places where each one of these happens, so there's actually like 6 total solutions to this. This is going to be great. This happens at pi over 4 plus some multiple of 2 pi n. It also happens at pi minus pi over 4, which would be 3 pi over 4 plus 2 pi n. So you notice these are the solutions for the cosine. These are the solutions for that part of it. Now, when is the sign negative rad 2 over 2? Well, that's going to happen at our other multiples of 5 pi over 4, basically. Or pi over 4, basically. So that'll be 5 pi over 4, as well as, that's 2 pi n, by the way, if you can't read that, as well as 7 pi over 4. So these are all of our general solutions. This is wonderful. Plenty of solutions. Now we just need to find all the ones that happen between 0 and 2 pi. Well, obviously you're only adding multiples of 2 pi here, so basically all of your answers are the ones that are there. So 3 pi over 2, pi over 2, pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. If you try to add 2 pi to any of those again, you end up with numbers that are outside of 0 or 2 pi. All right. Last one, cosine of 2x minus pi over 2 equals -1. Well, this is already set up for us nicely. Cosine's equal to a number, so I'm going to take the inverse cosine. So 2x minus pi over 2 equals the inverse cosine of -1. So you have to think about all the different places where cosine equals a -1. Well, there's a couple. So 2x minus pi over 2 could equal, if you look on your table, inverse cosine of -1 happens at pi plus 2 pi n. And the other option would technically happen at the negative of that, negative pi plus 2 pi n. But here's the kicker. If I were to add 2 pi n to negative pi, don't I get pi? So in this particular instance, these are basically the same solution. Okay, so I'm not even going to worry about this guy over here. Woo, I just completely deleted everything. I'm not even going to worry about that guy over there. I'm just going to do this. Now, obviously we still have some work to do. We need to add pi over 2. Well, pi plus pi over 2, that's technically 2 pi over 2 plus pi over 2. That's 3 pi over 2 plus 2 pi n. And last but not least, I need to divide everything by 2. So I end up getting x is 3 pi over 4 plus pi n. That's my general solution for this. And now I need to figure out what values will work between 0 and 2 pi. Well, obviously 3 pi over 4 is 1, because that's between 0 and 2 pi. Technically, I need to be between 0 pi out of 4, right? And let's see, this is x, not theta. And 8 pi over 4, that'd be 2 pi, right? So I can't go outside of those two. If I subtract 4 pi over 4, which is pi, right, I end up with negative pi over 4, which is not good. But I can add 4 pi over 4, and I get 7 pi over 4, which is still in our range between 0 pi over 4 and 8 pi over 4. If I try to add another 4 pi over 4, I get outside of that range. So those are the only two values that will work for this particular problem. All right? Hopefully these videos have helped make sense of some of the things that we've been doing lately. If there are any questions, please don't hesitate to contact me, all right? Just let me know. Come see me in the morning, and I look forward to you doing well on this quiz. Good luck!